Monolithic and microservice architectures are two different approaches to designing and structuring software applications. 1. Monolithic architecture. Monolithic architecture refers to an application design where all the components and functionalities of the application are tightly coupled and integrated into a single large codebase. In this architecture, the entire application is developed, deployed, and scaled as a single unit. The monolithic architecture typically consists of three main components: the user interface, business logic, and data storage. 1. These components are all combined into a single executable or deployment package. Advantages of monolithic architecture. 1. Simplicity. Monolithic applications are often easier to develop and test because the codebase is contained within a single project. 2. Performance. Since all components are tightly coupled, monolithic applications can achieve high performance as there is no overhead for inter-process communication. 3. Easier deployment. Deploying a monolithic application involves deploying a single unit, simplifying the deployment process. Disadvantages of monolithic architecture. 1. Scalability. Scaling a monolithic application can be challenging because the entire application needs to be scaled, even if only a specific component requires additional resources. 2. Flexibility. It can be difficult to adopt new technologies or frameworks within a monolithic architecture as changes may require modifying the entire codebase. 3. Fault isolation. A failure in one component of a monolithic application can affect the entire application, making it harder to isolate and recover from failures. 1. Microservices architecture. Microservices architecture, on the other hand, is an architectural style where an application is built as a collection of loosely coupled and independently deployable services. Each service represents a specific business capability and can be developed, deployed, and scaled independently. These services communicate with each other through well-defined APIs or message-based protocols. Advantages of microservices architecture. 1. Scalability. Each microservice can be scaled independently based on the specific requirements, allowing for better resource utilization. 2. Flexibility. Since services are decoupled, individual microservices can be developed and deployed using different technologies or programming languages. 3. Fault isolation. Failures in one microservice do not propagate to other services, making it easier to isolate and recover from failures. 4. Continuous deployment. Microservices architecture is well suited for continuous integration and deployment practices, enabling faster development cycles. Disadvantages of microservices architecture. 1. Complexity. Coordinating communication between multiple services introduces complexity, requiring robust service discovery, load balancing, and fault tolerance mechanisms. 2. Operational overhead. Managing and monitoring multiple services adds operational complexity compared to a monolithic architecture. 3. Distributed system challenges. Distributed systems introduce challenges such as network latency, data consistency, and transaction management, which need to be carefully addressed. It's important to note that the choice between monolithic and microservices architectures depends on various factors such as the size and complexity of the application, team capabilities, scalability requirements, and development timelines. Each approach has its own trade-offs, and the decision should be based on careful consideration of the specific project requirements. For example, 1. E-commerce application. Monolithic architecture. In a monolithic architecture, an e-commerce application would consist of a single codebase containing the front-end, back-end, and database components. All functionalities, such as user registration, product catalog, shopping cart, and payment processing, would be tightly integrated into the same application. Scaling the application would involve replicating the entire codebase and deploying it on multiple servers. Microservices architecture. In a microservices architecture, the e-commerce application would be divided into separate services. For example, there might be a user service responsible for user management, an inventory service managing product catalog and stock, a cart service handling shopping cart functionality, and a payment service processing payments. Each service would have its own codebase, API, and database. They would communicate with each other through APIs or message queues. Scaling can be done independently for each service based on its specific demands. For instance, during high traffic, the user service can be scaled separately from the inventory service. 1. Social media application. Monolithic architecture. In a monolithic architecture, a social media application would have a single codebase containing all functionalities, including user profiles, post creation, commenting, messaging, and notifications. The front-end, back-end, and database would be tightly coupled into one application. Scaling would involve deploying the entire application on multiple servers. Microservices architecture. In a microservices architecture, the social media application would be divided into different services. For example, there could be a user service managing user profiles, an activity feed service generating news feeds, a messaging service handling direct messages, and a notification service sending out notifications. Each service would have its own codebase, API, and database. They would communicate with each other through APIs or message queues. Scaling can be done independently for each service based on their specific needs. For instance, the messaging service can be scaled separately to handle increased message traffic. These examples demonstrate how the same application can be designed and structured differently using either a monolithic or microservices architecture. The choice depends on factors such as the complexity of the application, scalability requirements, development teams' capabilities, and operational considerations.